Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Region Thermo 3 by Red Barchetta. And here are the rules. Well, we have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have region sum lines, where box borders divide blue lines into sections with equal sums. The blue lines and their section sums may be the same as or different from other blue lines and their section sums. So, for example, these two digits must equal what this digit is because the box borders divide this line into two segments. This is a segment and this is a segment, and they must sum up to the same sum. So you could have something like, say, well, specifically, it could be 3, 5, and 8, because these two digits must sum up to the same sum as this digit does. And this also satisfies the slow thermometer, where digits may not increase as they move across the thermometer from the bulb end. So this could be 3, 5, and 8. Along this thermo, you could have essentially this being 5 and 5, and that would be valid. Well, actually, you can't have that as 5. But you could have this, say, a 6 and 6, and that would be valid. Because it's not decreasing along this line, and that's all we need to know for the slow thermometers. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so for long thermometers, I like going from the bulb to the tip, looking at each cell along the way, and saying what is the smallest this digit can be. Or so, yes, what's the smallest this cell can be, essentially. And then going back from the tip to the bulb, looking at what the largest those cells can be. And then it restricts those cells to those parameters. This is particularly useful for long thermometers, so I think we will do that here. So this is at minimum 1, because that's the lowest digit in Sudoku. This must be greater than it because it's in the same box and cannot be the same as it. So this is 2, 3, 4, 5, and 6. So that's the minimum these can be. This digit can be the same as this one. So because they are not in the same row, column, or box. So this is 6 at minimum, 7 at minimum, 8 at minimum. This digit is 9 at max. This is less than that because it's in the same box. Same with that. It's less than those two because they are basically in the same box as that. This could be the same as that, so it could be 7. This is less than that. 6, 5, 4, 3, and 2. So let's do that for all sort of the long thermometers. So 1, 2, 3, 4, 5, 6, 6, 7, 8. And it's the same thing here. Interesting. 4, 5, 3, 4, 2, 3, and 1, 2. What about this? We have 1, 2, 3, 4, 5. This could be a 5, technically, and then 6. But the problem is, okay, so if these digits were the same, then this digit would have to be equal to the sum of 4 other digits, which is not possible. And 4 unique digits. And because the minimum would be 1, 2, 3, 4, one digit can never add up to that. So this has to never be the same as this cell there. So therefore, we know this is 6 at most, 7 at most here. This could be 7, 8, 9. 9 could be, this is less than that, so it's 8. This again, cannot be the same as this digit, because if they are, then this digit is equal to the sum of 4 unique digits, which is not possible. So this has to be less 7, 6, 5, 4, 3. So this is 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, and 6, 7, 8. Okay. So the question is, what are these potential sums? Say we did have a 2 here. If we have 2, 3, 4, 5, 6, 7, what does that add? That would mean this adds up to the same as 7, 8, 9, which is 24. Does it? I don't think it does, right? So if we try, okay. 7, 8, and 9. So we're trying to make this 7. If we have 1, 2, 3, 4, 5, that doesn't add up to 7, 8, 9. What about 1, 2, 3, 4, 6, 7? Does that add up to 7, 8, 9? Okay, so these add up to 21. If you increase, so these add up to 21 at minimum. 1, 2, 3, 4, 5, 6. If this is 7, 8, 9, how many digits can increase? 7, 8, 9 is 24, so 3 digits at most can increase. So you cannot have 4, 5, 6, 7 here, because 4, 5, 6, 7 adds up to 20. Wait. 1, 2, 3, 4, 5, 6 adds up to 21. If we increase all of those by 1, so if we increase 3 through 6 up to 4 through 7, that's an increase of 4 from 21, which would be 25. Is that right? That doesn't seem right. Hold up. 1, 2, 3, 4, 5, 6 is 21. 1, 2, 4, 5, 6, 7. How are we Aren't we increasing each of them by 1? So shouldn't that add up to 25? Oh, it's 22. Yeah, it is 25. It's 22 plus 2 plus 1, which is 25. So this can never be 4 here, because if this is 4, 4, 5, 6, 7 adds up to 22, plus at minimum 2 and 1 adds up to 25, which 7, 8, and 9 can never get higher than. So this cannot be 4, so this is 3, this is 2, that's 1, and it's the same here. This is 1, this is 2, that's 3. Similarly here, this is at minimum 15. So, if we tried to have 5 here, 1, 2, 5, 6, well, you have 5, 6, 7, which already adds up to 18, which is impossible. So this doesn't work for 5. Can it work for 4? These have to be smaller because of these digits. Does it work for 4? 4, 5, and 6 is already 15, plus 2 and 1. So the answer is no. This is guaranteed also to be 3, 2, and 1 here. So this is 6. 6 and 7. So we have at minimum 15. We have at maximum 2 more digits to can have to add up to 8 and 9. Because 17 is the most these 2 digits can be. So you cannot go up to here, because then that would increase this digit by 2 also. That's an increase of 4 on that side. And 15 plus 4 is 19, which 2 digits can never have. So this cannot be 6. You could have a 5 here, though. Can you have a 7? 1, 2, 3, 4 is 10 plus 7. Yes. Okay. So this could be 1, 2, 3, 4, 5 with 6, 9. 1, 2, 3, 4, 6 with 7, 9. 1, 2, 3, 5, 6. 1, 2, 3, 4, 7 with 8, 9. 1, 2, 3, 5, 6, which also 8, 9. So those are all possible. Okay. So 1 can't be here, 1 can't be here in this lower left-hand box. 1 cannot be either any of these digits because actually this is the sum of 3 unique digits. So it must be 6, 7, 8, 9, but it cannot be 6 or 7 because of the 6, 7 pair in column 4. So this is 8, 9. We have an 8, 9 pair now in the central box. That eliminates 8 and 9 in the rest of the central box. So this can't be 8. That's 7. This is 6. That leaves this as 6, 5, and 4. 1, 2, 3, 4, 5, 6 adds up to 21. So that adds up to 6, 7, and 8, which means this has to be 9. So this is either 1, 2, 6, which it cannot be because of the 6 in the row here. 1, 2, 1, 3, 5, which it can't be because of the 5 in the row. So this has to be 2, 3, and 4. So this is 2, 3, 4 here, adding up to the 9. Where is the 1 in this lower left-hand corner? Cannot be here, cannot be here, can't be the 2, 3, 4 here. So it has to be 1 there. This is 6 eliminates 6 here, so this is 7, which makes this 8 and 9. So to add, this adds up to 24. So this has to be 5, 6, and 7, then guaranteed. So we have 5 here, 6 here, and that's 7 to add up to the same sum. 7 eliminates 7 here. This can't be 7 or 8. It's guaranteed to be 6, which means that this must add up to 15 at most, which it does have to be. So then this is 1, 2, 3, 4, 5, adding up to 6, 9. Okay. Remaining digits of this lower left box, or low central box. 9 can't be here or here, so 9 has to be here. This is 7, 8 then. 8 can't be here because of 8 in the column, so it's 7, that's 8. We have 6 digits in column 5, so the remaining digits must be 1, 3, and 4. Okay, and this can't be 1 because of 1 in the row. This can't be 3 because of 3 in the row. Where is 8 in this left central box? Cannot be here because of 8 in the row here. So this is 8 here, which leaves this as a 4, 9 pair. That eliminates 4 in the rest of the row. We have a guaranteed 1 here. Remaining digits in column 4. We have 2, 3, 4, 5. Okay, no 2, 3 here, no 2, 3 here. We now have a 4, 5 pair in column 4, which eliminates 4, 5 in the rest of the column. So this is 2 or 3. This is 2 or 3. Remaining digits of column 6. We have 1, 2, 5, and 6. This can't be 1 because of 1 in the row. This can't be 2 because of 2 in the row. No 5 because of 5 in the row. This can't be 1 because of 1, 5, or 6 because of 1, 5, or 6 in the row. So this is a 2, which makes this 3. That makes this 1, 4, and 5. 5 eliminates 5 here, so it's 4. 3 eliminates 3 here, so that's 2. 4 eliminates 4 here, so it's 3. And this can't be 2 because of 2 in the column. Remaining digits of row 4 are 2 and 5. This can't be 2 because of 2 in the column, so this is 5, which makes this 2. Remaining digits of row 5 are 1 and 8. This can't be 1 because of 1 in the column, so that's 8, which makes that 1. Remaining digits of row 6, we have 3, 4, and 7. And this can't be 3 or 4, so that makes this a 7. Well, That leaves this to be 3 or 4, which means if it's 4, this has to be 1 and 3, which is impossible because of the 3 in the column. So this must add up to 3. This is 4. This is 2 and 1 then to add up to 3. This can't be 4 because, again, that would be forces to be 1 and 3. And we can't have a 3 because of 3 in the column. So this must be 9, and that's 4. We have 8 digits in column 8. The remaining digits are 5 and 8. 5 can't be here because of 5 in the box, so this is 8. That's 5. In this upper right-hand box, remaining digits are 6, 7, and 9. This can't be 7 or 9 because of 7 or 9 in the row, so that's 6, which makes this 1. There's no 1 here. These becomes a 7, 9 pair here. Remaining digits. In column 7, we have 3, 7, and 9. This can't be 3 or 7 because of 3 or 7 in the row, so that's 9. This can't be 3 or 9 because of 3 in the row, 9 in the box, so that's 7, which makes this 3. Remaining digits in row 7, we have 7 and 8. This can't be 7 because of the 7, 9 pair in the column, so this is 8, that's 7. Remaining digits of row 8, we have 5 and 6. 5 can't be here because of 5 in the box, so that's 6, that's 5. That leaves this digit as a 4. Remaining digits in row 9 are 6, 8, and 9. This can't be 6 or 8 because of 6 or 8 in the column, so this is 9. This has to be a 6, 8 pair here. This has to be the low digit adding up to 9. So this is 1, 2, 3, 4 with 5, 6, 7, 8 here. And it cannot be 2, 3, or 4 because of 2, 3, 4 in the row. So this must be 1 and 8, which makes this not 8. This is 6, which makes that 8. We should have all the 1s, I believe, now. Yep. 2s. We have 8 2s. We know where the last 2 is. It has to be there. 3s. We have 8 3s. We know where the last 3 has to be. It has to be there. 4. We have 8 4s. The last 4 then has to be there. 5s. Okay, in column 3, 5 cannot be anywhere except here. So this is 5, which makes this 6, which makes that 5. And that gives us all the 5s. 6s. We have 8 6s. We know where the last 6 is. It's there. 7. In column 2, 7 has to be here, so that makes this 7, which makes this 9, which makes that 7, which leaves the last remaining digit as a 9. And that's a solution. Pretty cool way that this interacted, actually. I chose this actually because of it had high ratings, and it makes sense. It flowed very well throughout, and was very solid. Yeah, don't know what else to say about this. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.